Okay, I'm going to be talking about polynomial division. We're going to do this in three parts. Long division, which is useful for all polynomial divisions. Synthetic division, which is useful for dividing by x plus a number or x minus a number. And facts about division. So we'll start with long division. And we're going to refer to this document. We're going to be basing this off the first page of this document. Long division of polynomials, my way. And as you can see, we're using the same example. Okay? So follow the steps that are on the top of this page, and that's what we're going to be doing here. Okay? So we would divide the first term by the first term. Okay? Divide first term by first term. First term by first term. So 2x squared divided by 2x is just x. Okay? Then, I put it on top. Then you are going to take the x, the division result, and multiply it by the divisor. 2x plus 5. And I get 2x squared plus 5x. Okay? Now, you're going to want to subtract this from this, except here's how I would recommend you subtract. Change the signs and add. So we will be adding a negative. You're going to want to change the signs. Negative 2x squared minus 5x. Okay? So I had two positives. Now I have two negatives. Okay? This gives me 12x plus 33. My next step is to take this and put it in and set up a new box. So 2x plus 5. And this is going to go in a new box. Okay? And then we'll repeat the process. Divide first term by first term. First term divided by first term. That gives me 6. Put it on top. We're also going to take 6 times the divisor. So we end up with 12x plus 30. And then we're going to change the signs. Okay? So we will be adding a negative 12x and a negative 30. Change the signs and add. 2 pluses become 2 minuses. That gives me 3. Okay? The power here is less than the power here. That's x to the nothing, that's x to the first, so that's going to be a remainder. Okay? So we have the quotient is x plus 6. The remainder, 3. Okay, so some books only expect you to do x plus 6 for the write down quotient and remainder. Okay, some will prefer this notation. X plus 6 remainder equals 3. Okay? Others will prefer x plus 6 plus the remainder over the divisor. Okay? This would be quotient plus remainder over the divisor. Okay? So this is one notation, another notation, and then another. Okay? three notations to describe this situation. Okay? All right. So I'm going to get this off the board. I'm going to do another example. Okay? Example 2, not on paper. It's not on the paper. It's 2x cubed plus, sorry, wrong one. 5x to the fourth plus 2x cubed minus 47x squared minus 9x plus 47 divided by x squared minus 8. All right, again, we're still on long division. So we'll have x squared minus 8, and then 5x to the fourth plus 2x cubed minus 47x squared minus 9x plus 47. Okay? Continue to follow the steps that are on the first page, okay, of this handout. So divide first term by first term. So 5x to the fourth divided by x squared gives me 5x squared. You will take that 5x squared and multiply it by the divisor, x squared minus 8. And you will get 5x to the fourth minus 40x squared. Okay? And then we will change the signs. Change signs. And add. So plus negative 5x to the fourth plus 40x squared. The first term cancels, which is what it's supposed to do. So we will have 2x cubed minus 7x squared minus 9x plus 47. Okay? Then we will repeat the process. I'll have x squared minus 8. Now put this in a new box. Okay? I will divide the first term by the first term. First term by first term. And that leaves me 2x. You will also take that 2x times x squared minus 8. And you will have 2x cubed minus 16x. We're going to change the signs. Okay? So we will be adding a negative 2x cubed and a positive 16x. Oops. Needs to go under but it needs to go under its like term. Okay? And that will leave me negative 7x squared plus 7x plus 47. Okay, and then this is going to go in a new box. Negative 7x squared plus 7x plus 47. Divide first term by first term. And you end up with negative 7. You will take negative 7 times the x squared minus 8, and you will get negative 7x squared plus 56. And then we're going to change the signs. Okay? So we will be adding a positive 7x squared and a negative 56. Leaving me, that cancels. This leaves me 7x minus 9. Because the degree here is less than the degree here, we're done. That's the remainder. The power here is 1. The power of x is 1. The power of x here is squared. So the power here is less than the power here, we're done. Okay? The quotient is 5x squared plus 2x. Oh, I forgot to put the minus 7 here. Okay? You could, if you forget to put them on top, you can always recollect them by taking these and putting them together. So 5x squared plus 2x minus 7. Okay? The remainder, 7x minus 9. Okay? So that's one notation. Another is 5x squared plus 2x minus 7. Remainder equals 7x minus 9. That's another. And another is quotient. Another notation is quotient. 5x squared plus 2x minus 7 plus the remainder, 7x minus 9, over the divisor. Okay, that's another notation. All right, so let me get this one off the board, and we're going to do an example 3. Not on paper. Example 3, not on paper, is, I have it, you don't. X cubed minus 14x squared plus 43x minus 12, and we're going to be dividing by x minus 4. Okay? Okay, so my first order of business is to set up a division box. X minus 4 and x cubed minus 14x squared plus 43x minus 12. Okay, divide the first term by the first term. And that gives me x squared. Put it up here. I will also be taking x squared times the x minus 4. Leaving me x cubed minus 4x squared. Okay? I will go ahead and add the opposite. Change signs, and we have negative x cubed plus 4x squared, which gives me negative 10x squared plus 43x minus 12. And this will go in a new box. Negative 10x squared plus 43x minus 12. Okay? Now repeat the process. Divide the first term. Divide the first term by the first term. I get negative 10x. So negative 10x will go up here. I will take negative 10x and multiply it by x minus 4. Distributive property will give me negative 10x squared plus 40x. Okay? And then we're going to want to change the signs. So, we will be adding a positive 10x squared and a minus 40x. Okay? And that leaves me 3x minus 12. My next order of business is a new division box where I divide this by the original divisor. Okay? Divide the first term by the first term. So 3x divided by x is just 3. First term divided by first term. Okay, not just 3. I will then take the 3 times the x minus 4 that I'm dividing by, and I will get 3x minus 12. We're going to change the signs and add a negative 3x and a plus 12. There is no remainder. Okay? Put that 3 up there. There's no remainder. So all I have is x squared minus 10x plus 3. That's the quotient. The remainder is 0 or no remainder. Okay? So now, I will move on to synthetic division. And I'm going to be referring at first to this handout. We will do all 3 examples, and then we will go off the paper to new examples. Okay? So, I will be doing the same problem. X cubed minus 14x squared plus 43x minus 12 divided by x minus 4. Okay, I'm going to be doing it by synthetic division. Okay, what I do is I'll have a box, and then I'm going to put all the coefficients and the constants. Well, I don't need the plus 43. Just 43 minus 12. That's the constant. Coefficients are 1, negative 14, 43. And the constant is negative 12. I will add I generally include a plus here in parentheses. You need to leave space for numbers. You need to have an entire empty row here. Okay? Now this is something I've started doing the last few years, and that is putting a portion of a box under the last term. Okay, that would delineate my remainder if I had one. Okay, so make sure that this is an empty row. There should be no numbers here for now. Make sure that every power of x is counted for, and it is. 3, 2, 1, nothing. Now what goes in this box is the opposite of minus 4. So plus 4. Okay? Now, the first thing you're going to do is drop down this 1. Whatever's here, drop it. Now multiply this, whatever comes down, multiply by the 4. So 1 times 4 is 4, and you'll put the answer here. 4 times 1 is 4. Put that in the next column, the empty row. Think of it as bouncing. Okay? 4 times 1 is 4. Bounce 4. And then you will add these as negative 10. Next you will take that negative 10 times the positive 4. Negative 10 times positive 4 is negative 40. Bounce it into here. Okay? You'll get 3 when you add. Next you will take the 3 times the 4. That's 12. So 4 times 3 is 12. Boing. 12. Okay? When you add those up, you get 0. And then from there, you count down. Okay? You'll start, for the powers of x, you count down. So start 1 power lower. 1. This was x cubed, so it'll be x squared. Minus 10x the first. 2, 1, nothing. So, and then plus 3. So x squared minus 10x plus 3. It is faster, it's quicker, it takes less space. The problem is that synthetic division only works when you are dividing by x plus a number or x minus a number. Okay? So of all the long division examples, we did 3 long division examples. Only this one was doable by synthetic division. Examples 1 and 2 were not. Okay? Only useful when dividing by x plus a number, x minus a number. No x squared, no 2x, 3x, okay, none of that. Okay, you can't do synthetic division on anything except x plus a number or x minus a number. Okay? So that's the reason, and we also generally teach long division first, so students appreciate synthetic division more. Okay, for obvious reasons. Okay, so let me do this again. Okay, we're going to do it again. Nothing wrong with the previous administration of the problem, but we're going to do it again. We've got an empty box. 1, negative 14, 43, and negative 12. Plus for an empty row, and I'm going to put a line under it. A line under it. Make sure there's room for numbers here, because there will be numbers here. Another thing I do is I put a portion of a box right underneath the remainder, or right over the constant. The opposite will go in the box. Drop down the 1. 1 times 4. You'll multiply these. It's a multiply, add, multiply, add, multiply, add cycle. So drop, multiply. 1 times 4. Boing, 4. Okay, negative 4, or you get negative 10 when you add these two. And then you will multiply. Negative 10 times 4. Bounce it into the next column. So negative 10 times 4. negative 40. Boing. 3. 4 times 3. Boing. 12. 0 is your remainder. So the power of x was x cubed originally, so we will start with 1x squared, and then minus 10x plus 3. Okay? Okay, example 2. Okay, example 2. A synthetic division. Three x to the fourth minus 71x squared plus 19x minus 11 divided by x plus 5. All right. I got me a box. And before I do this, let me explain something. You have to account for all the powers of x. So the powers of x go 4, 2, 1, nothing. There's no x cubed here. We have a skip power. So we need to treat this as 3x to the fourth plus 0x cubed minus 71x squared plus 19x minus 11. Okay? So, 3, 0, negative 71, 19, and negative 11. Plus an empty row for now, and then I got my little part of the box down there as well. I'll mark off the remainder. The opposite of plus 5 is minus 5. Okay? Bring down the 3. 3 times negative 15. Negative 5 is negative 15. Add these up, you get negative 15. Negative 15 times negative 5 is positive 75. And we get 4 when we have it. Okay? 4 times negative 5 is negative 20. Add these up, you get negative 1. Negative 1 times negative 5 is 5. Boing. Negative 6. Okay? That will be my remainder. So this was 3x to the fourth, so we will start with 3x cubed. And then we count down. Minus 15x squared plus 4x to the first minus 1. Okay? So the quotient, the remainder, so the quotient is this, 3x cubed minus 15x squared plus 4x minus 1. The remainder, negative 6. Okay? One notation. Here's another. Okay? Another notation would be to say we have 3x cubed minus 15x squared plus 4x minus 1, capital R for remainder, negative 6. That's another notation. Another notation is to use 3x cubed minus 15x squared plus 4x minus 1. Okay, now, here's the thing. The remainder is negative 6, correct? So when you're adding a negative, it's the same as subtracting. So minus 6 over x plus 5. Okay? Because adding the negative 6 would be the same as subtracting the negative 6. And then you put it over the divisor. Okay? Example 3. Factor 2x cubed minus x squared minus 21x plus 18 given that x minus 3 is a factor. Okay, so you know that x minus 3 is what a factor. To get the other one, you divide. Same with arithmetic. Okay, if somebody was to tell you that 5 is a factor of 55, to get the other factor, you would have divided by a 5. Okay, you're going to do the same thing here. So divide. So we will have 2x cubed minus x squared minus 21x plus 18 by x minus 3. Box 2, negative 1, negative 21, and 18. The opposite of minus 3 is positive 3. Bring down the 2. 2 times 3 is 6. I get 1, or I get 5, sorry. 3 times 5 is 15. I get negative 6. 3 times negative 6 is negative 18, and I have 0. Okay, that's my remainder. So it's 2x squared plus 5x minus 6. Okay, so the factors are going to be the quotient, forgot my x squared, and the x minus 3. Okay? And factored. Factoring result. Again, remember, this wasn't a straight division problem. It asked you to factor. Okay? Okay, so I'm going to be moving on to more complex examples. Okay, so you don't have these on paper. Examples not on paper. Example 4. Divide 2x cubed plus x plus 460 by x plus 6. Okay? Note that you're going to need to treat this as 2x cubed plus 0x squared, because we go from x cubed x to first, plus 1x plus 460. So, 2, 0, 1, 460. Plus an empty row. And the opposite of plus 6 is minus 6. Bring down the 2. 2 times negative 6 is negative 12. We get negative 12. Negative 6 times negative 12 is positive 73. Okay? All right, now I had a calculator over here somewhere. It looks like I might have misplaced it. Well, for now, I'll just go ahead and multiply that one. So that'll be 74. And 74 times negative 6 4, 24. I'll put the minus on loud. Okay, and then, well, yeah, looks good to me. So minus 444 is 16. All right. I see what happened. I got it ahead of time. Okay, we're going to start this over. Okay, starting over. Trying again. Okay. So, we're going to have negative 6, or we're going to have 2, 0, 1, 460, plus, okay, the opposite of positive 6 is negative 6. Bring down the 2. 2 times negative 6 is negative 12. Add them up, you get negative 12. Negative 6 times negative 12 is positive 72. When you add them, you get 73. Okay? Negative 6 times 73 is negative 438. Okay? And that's 22. Okay? So my quotient is quotient remainder. Okay, quotient is 2x squared minus 12x the first plus 73. My remainder is 22. Okay, so a common way that this would be written in some textbook and programs combined would be 2x squared minus 12x plus 73 plus 22 over the x plus 6. Okay? I'm going to pause this and go find that calculator. Okay. So resuming, I'm going to put another example on the board. Example 5. Again, you don't have these on any handout that I've given you. X to the 4th minus 10x squared plus 31 divided by x plus 1. So this is to be treated as x to the 4 plus 0x cubed minus 10x squared plus 0x plus 31. Because we got skip powers of x. It goes from 4 to 2 to nothing. Every power of x must be accounted for. So I'll have 1 for x to the 4th, 0 for x cubed, negative 10, 0, and 31. Okay? The opposite of positive 1, of plus 1 is minus 1. Okay? Bring down the 1. 1 times negative 1 is negative 1. Okay? Add these up, you get negative 1. Negative 1 times negative 1 is positive 1. We get negative 9. Okay? And then from negative 1 times negative 9 is positive 9. That's 9. Negative 1 times negative 9 is negative 9. So I get 22. Okay? So it's quotient remainder. That's 1x to the 4, x cubed, minus 1x squared, plus minus 9x. Let me move this over. Quotient remainder. x cubed, so we go down a power, minus x squared, 1x squared, minus 9x plus 9, with the remainder, once again, 22. Okay? So just to clarify, one notation, and then another. I'm not going to do two of those again, okay? All right. Example 6. Negative 3x squared plus x squared plus 17 divided by x minus 1. Okay? So this should be x cubed, pardon me. Which needs to be treated as negative 3x cubed plus x squared plus 0x plus 17. Because we went from 3, 2 to x to 0. We got to count for every power of x. 3, 2, 1, nothing. So, box, negative 3, 1, 0, and 17. Okay? I'm going to put a portion of a box under here. The opposite of minus 1 is plus 1. So, bring down the negative 3. Negative 3 times 1 is negative 3. You get negative 2. 1 times negative 2 is negative 2. Add them up, you get negative 2. 1 times negative 2 is minus 2. That's 15. Okay? So, we have quotient, remainder, the quotient is negative 3x squared, goes down a power, minus 2x the first, minus 2, and the remainder is 15. Okay? I'm going to pause here. Okay. Now, we've done long division, we've done synthetic division. I'm going to talk about a couple theorems. The first one is the remainder theorem. The remainder theorem says that if you have polynomial some polynomial f of x, then the result of a polynomial division by x minus that number, by x minus some number, is the same as f of that number. So, for instance, we've got this polynomial function. F of x equals x cubed minus 5x squared minus 4x plus 26. Okay? And we have x plus 2, which is the same as x minus negative 2. Now, if I do direct substitution, f of negative 2 would be negative 2 cubed minus 5 times negative 2 squared minus 4 times negative 2 plus 26. And that's negative 8. Negative 2 squared is 4, times negative 5 is minus 20, plus 8, plus 26. So, that's 6. Okay? So f of negative 2 equals 6. Now, watch what happens if I do a polynomial division problem involving x minus negative 2, which same is divided by x plus 2. So we have box 1, negative 5, negative 4, and 26. Okay? I'm going to move this. Okay? All right, so opposite of positive 2 is negative 2. I'm going to put that a little bit of a box there. And we have going to go ahead and do this division. Okay, so we have 1, -5, -4, and 26. Bring down the 1. 1 times -2 is -2. We get -7. -2 times -7 is +14. We get 10. 10 times -2 is -20. We get 6. Okay? Which just happens to be f of -2, which we see by direct substitution. So the quotient is x squared minus 7x plus 10, and the remainder is 6. Okay, now, and find f of -2 using synthetic division substitution. Okay, because in this context it's interchangeable. You're trying to find a function value. Okay, so box, we got 1, -5, -4, 26. In the context of synthetic substitution, you plug in the actual value. Okay? So, we got 1. -2 times 1 is -2. We get -7. -2 times -7 is 14. That's 10. -2 times 10 is -20. That's 6. Okay, which is f of -2 equals 6. Okay? So this procedure gives us 3 pieces of information. It gives us a quotient, it gives us a remainder, and it gives us a function value for that number. Okay? So, as I said, you have polynomial f of x, and you've got the remainder of the function divided by x minus a number is the same as f of that number. So here we had a function and we had x plus 2, which is equivalent to x minus -2. So when you divide by x plus 2, you would have -2 in the box. That gives a quotient, that gives us a remainder. And that remainder is, the result is the same number as you'd get if you plug the number directly into this. Okay? Next thing. Okay. I'm also going to discuss something called the factor theorem. X minus c is a factor of polynomial f of x if and only if division leaves a remainder of 0. So, for instance, we know that this is factorable because 2 factors of x, you got x squared, you got x and x, 2 factors of 15 that add up to 8 are 3 and 5. Okay, so I'm going to test both of these, confirm this by dividing by both, x plus 3 and dividing by x plus 5. Okay, so 1, 8, 15. The opposite of 3 is -3, which leaves me 1. 1 times -3 is -3. That's 5. -3 times 5 is -15. That's 0. And the quotient is x plus 5. Okay? Okay, over here, if I divide by x plus 5, I will still have 1, 8, and 15. Okay. Now, opposite of 5 is -5. Bring down the 1. 1 times -5 is -5. I get 3. 3 times -5 is -15. I get 0. That's my remainder. Okay? So the quotient here is x plus 3. 1x plus 3. Now, over here, this is common. Okay? So, x plus 1 is not a factor. Or x minus 1 is not a factor, correct? Why did I pick x minus 1? Why not? Okay? 1, 8, 17. So the opposite of negative 1 is positive 1. Bring down the 1. 1 times 1 is 1. That's 9. 1 times 9 is 9. That's 26. Okay? The quotient is x plus 9. The remainder, 26. Okay? So, it's not a factor. Okay? X plus 1 is, or x minus 1 is not a factor. Okay? Remainder isn't 0. Okay? These are factors, and the remainders are 0. Okay? So, that is the final, that is a final, one more illustration. One more fact. Okay, here's another one. Definition. A zero of a polynomial f of x is a value of x equals c such that f of c equals 0. Okay, so for instance, illustration. Let x equal and let f of x equal. X squared minus 2x minus 24. Okay? And we will let x equal we will let x equal 6. Okay? Okay? If we solve x squared minus 2x minus 24 equals 0, we would have x plus 6, x plus 4, x minus 6. So x plus 4 would have to equal 0, x minus 6 would have to equal 0. Subtract 4, x equals negative 4. Add 6, x equals 6. So the zeros, or roots, they mean the same thing, of f of x equals x squared minus 2x minus 24 are x equals negative 4 and 6. We solved it by factoring. Okay? Now, look at what happens if I plug x equals 6 into f of x by direct substitution plug x equals 6 into f of x by synthetic substitution. Okay? Well, f of 6 would equal 6 squared minus 2 times 6 minus 24. 36 minus 12, minus 24, 0. X equals 6 is a 0 because it would make this equal 0. Okay? So, now we're going to plug it in as a function value. X equals 6. Okay? So, 1, negative 2, and negative 24. That's why I do that last box last. Okay, so we have 1. 1 times 6 is 6, that's 4. 6 times 4 is 24. That's 0, which is f of 6. Okay, note, division by x minus 6 would leave a quotient of x plus 4 and a remainder of 0. Okay? All right, and I'm going to stop there.